Let's talk about the expression for the displacement in a wave motion. So here we have a transverse wave having wavelength lambda, that is the distance from here to here, or the distance from two consecutive crest or two consecutive trough, that is the wavelength. So this wave is a plane progressive wave which is moving along plus x axis, and these are the particles of the medium P1, P2, P3, P4, P5. You may take any particles on the wave, P6. By the way, let me clarify what the wave is. Here we have a long rope, long straight rope. You may consider something like this. Long straight rope, and these are the particles P1, P2, P3, P4, P5, P6 and so on. Now you are giving a jerk like this, so a wave is created. So all the particles, some will go up, some will go down, because now the shape of the rope will be something like this. So this particle will reach here, this will reach here, this will be reaching here, this will stay here, this will again go up. So all those particles are being shown over here. Okay. Now, if I say that if I want to find the phase of this particular particle P5, now just now you have seen this particular animation, and this animation has already clarified many things. Like you need to see how much part of the wave is ahead of this. You may see very well that all particles of the medium, they oscillate with the same amplitude as that of the wave. Second thing, they all oscillate up and down with same frequency, same time period. Okay, so you may very well guess from here that what would be the phase of P5. The trick is, a lot of the students, they don't understand this. Just draw a dotted line. See how much part of the wave is above this particle P5. Correct? So you may see in the direction of wave, you may see one complete wave is ahead of particle P5. That means this one wave has already passed through this particle P5 and it has already completed its one oscillation, thereby gathering the phase of 2 pi. Because we know in SHM very well that if one particle completes oscillation, it gathers 2 pi phase in its bank account. Now, in the same way, if I talk about particle P2, then I'm seeing one complete wave and two complete waves passing through this particular point P2 or the particle P2. So there are already two waves which have already passed through this particular particle. So it has completed two oscillation, thereby gathering the phase of 4 pi, because one time oscillation, 2 pi is the phase, two times oscillation, 4 pi is the phase. In the same way, if I talk about particle P1, then its phase will be how many waves are ahead of it? 1, 2 and 2.5. So this particle has already completed 2.5 oscillations, thereby gathering a phase of 5 pi. Before going into this one, you must understand the concept of phase. So if you have any doubts, please log in to the link which is given in the description. All right, fine. Now, in the same way you may find out the phase of all these particles. Let me give you an answer to this one. How much phase should be over here? 5, 6. 1/4 of the wave is ahead of it. That means this particle has finished 1/4 of the oscillation. So pi by 2 is the phase. This wave is going in plus x-axis. So the first thing is, in the direction of wave, the phase of medium particles decreases. How come? Look at this. This particle has phase 5 pi, then 4 pi, then 2 pi and pi by 2. And what about this particle? Let me call this particle as P7. Now the particle will start going up because no part of the wave is ahead of it. So its phase is 0. So you may consider this very well, and you may see this very well. In the direction of phase, in the direction of the wave propagation, the phase keeps on decreasing. Okay. Now when the wave passes through the particles of the medium perform SHM, and the displacement of the SHM equation is y is equal to a sine omega t plus phi. Okay. Now let me give a clue that this particle is at the origin. We are considering this part of the rope to be at the origin. So if let me take this value as 0. We know that the phase is 5 pi, but if I take this as 0, the phase of all will be negative. This is the highest phase. If this becomes 0, the others will become negative. Okay, because in the direction of the wave, the phase decreases. So if this is 0, this has to be something negative. Okay. Now one more important thing is, you look at particle P2 and you look at particle P5. What is the distance between particle P2 and P5? Lambda. Look at this, one complete wave. So the distance is lambda. So that means if lambda is the path difference means distance between two particles is regarded as the path difference. So if the path difference is lambda, the phase difference is then delta phi, that is the phase difference is 2 pi. Look at this, 4 pi minus 2 pi. So the difference in phase is 2 pi. Let me take another example. The phase of this is 0, the phase of this is 2 pi. So they are lambda distance apart. So if the distance between both of them is lambda, the phase difference is 2 pi. Okay, so if you go lambda distance ahead from this particle, 2 pi phase decreases. So in the same way, now I'm going to call this as 0. Okay, and I'm going to take this particle number P4, this one. say at a distance x. This particle P4 is at a distance x from the origin. So here x is equal to 0, here x is equal to x. So P4, so P1 and P4 are at a distance which is basically path difference, and path difference is represented by delta x, that is x. Why? Because the distance between P1 and P4, that is the path difference. Symbolically it is known as delta x. And what is the difference that I have selected? X. Because this is 0 and its coordinate is x minus x is equal to x. So the distance between these two particles is x. Now we are going to use this. If two particles are at a distance of lambda, 2 pi is the phase difference. If x is the path difference, then the phase difference should be delta phi. That means cross multiply delta phi is equal to 2 pi by lambda times x. This 2 pi by lambda is known as k. So that is kx. So which means if I take this phase as 0, then the phase of this particle P4 is 0 minus kx. Once again, if the gap between two particles is lambda, then the phase decreases by 2 pi, like from 4 pi to 2 pi. In the same way, if I take this as 0, then these two are at a gap of distance x. Correct? So that means the phase difference between these two particles must be kx, and in the direction of wave the phase decreases. So if this is 0, then kx must be the decrease in the phase. So this phase is minus kx. Now let me write down the equation for particle P1, because all the particles are performing SHM. So y particle P1 is equal to a sine omega t plus 0, because I have considered the phase to be 0. Then what about this particle P4? A, because all particles will oscillate with same amplitude as that of the wave, sine same frequency, minus of kx, because if the phase of this is 0, the phase of this is this minus 0. So if I take the phase of this as omega t, then the phase of this will be omega t minus kx, right? This is known as a wave equation in general wave equation. Now understand what this means. If at any time t, if I fix the coordinate x, suppose if I say that x is 10 centimeters. Let me imagine one particle over here which is at a distance 10 centimeters from here. So I can very well substitute what is x. Let me give you the clue that at 2 seconds, then I might plug in the value over here as 2. Displacement, or sorry, the amplitude of the wave will be given to you. You may plug it over here. We will give you the frequency of the wave. You may plug it over here. You will get the displacement of the particle at that distance at that moment. So if you put in any two values over here, you may be able to understand very well about the displacement of that particle at that particular moment. So that is the wave equation.